Okay, in problem 19, we have an 8-kilogram stone sitting on a spring, and by putting it on the spring, we compress the spring by 10 centimeters. So in part A, they're asking what is the spring constant. Now remember, the spring constant K is the force per unit length that it takes to compress the spring. Well, in this case, what is the force? The force is 8 kilograms times 0.1 meters. 8 kilograms times 9.8 meters per second squared. And what is the distance? 0.1 meters. Right? So we've compressed the spring 8 times 9.8 divided by 0.1. All right. That gives us 8 times 9.8 divided by 0.1, 784 newtons per meter is the spring constant. Part B. The stone pushed down an additional 30 centimeters and released. What is the elastic potential of the compressed spring just before that release? Okay, so you got to remember that the elastic potential of a compressed spring is 1/2 kx squared. Right? So we have 1/2 of 784 newtons per meter times x. X, however, is not 30 centimeters. We've already taken it down 10 centimeters when we compressed it the other 30. So this is 0.4 meters squared. All right. So 1/2 times 784, 1/2 times 784 times 0.4 squared. So 62.7, right? 62.7 joules is the energy stored in the spring at that point. Part C. Okay. Part C. What is the change in gravitational potential energy of the stone-earth system when the stone moves from the release point to its maximum height? All right. So if we consider, the lowest point the stone is at to be its 0 point for gravitational energy, that means that the total height it's going to go to is given by the total energy stored in the spring. Right? Energy is conserved. So what we're looking for is for mgh, the height of the rock, to be give us 62.7 joules. Well, we know m, we know g, so the height is 62.7 joules divided by, all right, the mass, 8 kilograms times 9.8 meters per second squared. All right, 62.7, that divided by 8 divided by 9.8 gets us 0.8 meters. 0.8 meters or 80 centimeters is the height it goes to. And that is above the release point. All right. What is change? Oh, what is the change in gravitational potential energy of the stone-earth system when the stone moves from release point to its maximum height? And that is 62.7 joules. All right. 62.7 joules. That's all the energy stored in the spring. All of that gets converted into gravitational potential energy. So it goes up to 62.7 joules in energy in the gravitational field. And then they ask the last part, the part I've already plowed through on part C and answered, part D, what is that height measured from the release point? And it is 80 centimeters. And that is it for problem 19.